Okay, well, let's just go ahead. Apparently we're two panelists down, and usually when you're a moderator, you have a couple questions, and then you kind of rely on the panelists to just ramble on and on to fill out time. So that strategy is really not going to work here, so we're going to fly by the seat of our pants a little bit and get a little bit reckless. So if you guys have any questions or want to get engaged in the conversation, just go ahead and jump in. But we're here today to discuss how writing code should be, or should it be, kind of a core part of the curriculum. If so, at what stage of life is it appropriate to introduce it? To what degree should we expect people to be competent programmers as a profession, or just kind of know what it is and have experienced at some point in their lives? And kind of the nuances of all of these questions. To set a little bit of context, there are 1.5 million jobs open right now in software engineering, and they simply can't be filled because not enough people have the skill sets to actually get those jobs. And each job has a multiplier effect as well. So an economist recently wrote that for every high-skilled job that we fill, we create 3 additional jobs in the economy. So the recession led to between 9 and 10 million jobs being lost. So, almost just with filling those software engineering jobs, we could get back up to near the employment rate that we had pre-recession. Why don't you go ahead and introduce Tinker and talk about what you do?
Okay. So my name is Krishna Vedati. I'm one of the co-founders and CEO of a company called Tinker. Tinker provides a creative computing platform for elementary, middle, high schoolers where they do fun activities that they like building games and doing stories and animations, and controlling robots. In the process, they learn how to program. That's what Tinker does.
Mm-hmm.
What age would that be?
So the thing starts at ages 8. We have seen up to 7. Some schools using at 7, but 8 they need to have reading skills and some math skills. That translates them to be able to create this.
Mm-hmm. And a little background on me. My name is Michael Staten. I started a company, Integral, which is very involved in higher education, enrollment management, things along those lines. I'm now a partner at Learn Capital. And somewhere along the side, I also got very involved in a company called Dev Bootcamp, which is a bootcamp type learning environment that teaches people to become beginner-level software engineers, world-class beginners is what we call them, in just 9 weeks. And within 3 months of graduating, 90% of the graduates get jobs starting at around $80,000 a year. So that's gotten a lot of attention, and I've written about that. So that's kind of my interest in this. When I was teaching high school, I had to teach myself to code. It was a very arduous experience. As soon as the company got started, my software engineering co-founders kicked me off the code base because I was so bad. But it was a requisite skill set to being an entrepreneur these days. Because basically all new startups are now technology startups. They all use the web or a mobile device as a market entry point. So that's some background there. Let's discuss the idea of kind of coding as a literacy, right?
Yeah.
So is technology the new paper? Is it just a medium? Like is it necessary for the 21st century and the 22nd century?
So I guess if you think about
last minute panelist. All right, cool.
Coding as a new literacy, coding, or what we call, what I think is a computational thinking is a kind of skill that just like a kid can learn French or Spanish. So if you learn French, Spanish, or Mandarin, you get a set of skills that you can interact with the world in their cultures, in their language. But if you learn a computational thinking or coding skills, you get to bring out your creations, in your imagination into a digital world in different ways. It need not be always, for example, if you look at how technology is changing, 5 years, the jobs that existed, some jobs that existed 5, 6, 10 years back don't exist now. If you look at travel agents, a lot of them got replaced by technology. Accountants, like, that's replaced by software. If you think about even like, receptionists are getting replaced by, ZocDocs of the world. So technology is playing a massive role, and our kids are so exposed to technology, whether like if you look at least in the countries like US, advanced countries, kids are exposed to Google, YouTube, Netflix. You think about what they're learning constantly yet, and they become constant consumers versus makers. So this skill, this language skill, can give them to become these digital makers for their generation.
Jake, you want to jump in and introduce
Sure.
yourself?
Sure. I'll leave Neil's space right here. It's a special spot for Elijah or something. Okay, so I'm Jake Schwartz. I'm one of the co-founders and the CEO of General Assembly. We started as an entrepreneurial community in New York City and started offering classes, and those classes became courses, and now we have about a dozen full-time to part-time programs that really mostly college graduates pay to take in order to either level up at their current career or start a new career trajectory. And we have a lot of career support services, community services, and really all around this idea of helping people become less lost and lonely in their careers. And the reason why it makes any sense at all for me to be on this panel is that we started, and a core part of our business is teaching coding skills to that audience, which is, tends to be college graduates. I joke it's typically like Dartmouth philosophy majors who want to get a job doing something useful. So we've been, had to do a lot of thinking. We've invested a lot of time developing curriculum around how to teach people coding. And it's one of the verticals we do. We also do design and business, but in a lot of ways, coding is the easiest to do because it's such a clear outcome and it's such a clear sort of skill that people talk about as being necessary in this, modern world. And so to your point, it's sort of like it has that output at the end of it, which seems to make people really excited to get engaged in it. What was the question?
Is coding the new literacy?
Yeah. So I think my take on it, now besides starting this, I've also sort of, as part of it, I taught myself, how to code a bunch of different times, tried, when I was in college, and then a couple times afterwards. Lynda.com was a big help at some point, and there's so many free resources on how to do that. And the one thing, once I finally got into it, what I realized is that it is, because of the history of computer science, it was mostly developed by mathematicians. It's an incredibly mathematical language, and it's math in what I would call an iterative context, where you can formulate an equation, try to make it work. If it doesn't work, it's very easy to go back and try to fix it to make it work again. Mm-hmm. And so, as opposed to a literacy, which I think, yes, everybody should have some degree of literacy on how this stuff works. But it's also constantly changing, and there's front end and there's back end, and it means a lot of different things to a lot of different people. One of the reasons I think as a core curriculum that coding would be so interesting is that it's a great way to learn and teach math. And to teach quantitative thinking outside of rote memorization or putting pencil to paper and just doing a lot of long division. And I've been sort of saying for a while that I actually think after algebra, advanced math should all just be taught using a computer and trying to code, solutions to problems. Mostly because it is just a perfect venue for doing that, and it's how most of those complicated math problems get solved in the modern world anyway.
That's funny because maybe this is why I got kicked off the code base, but I always thought it was more analogous to poetry, where it was it's the search for the perfect syntax, the perfect way to phrase things. Mm-hmm. That being concise and elegant is better than being, wordy and.
Some people would say math is the best poetry.
Okay.
So most
that's true, I guess.
One small take. I'm actually classically trained computer scientist, so I went undergrad computer science, master's. I've written 2 books on programming. So one thing about this, the reason I want to kind of point that out is that programming is not computer science.
Correct.
Programming is a tool. computer science has a massive, like, operating systems, the things you're using, databases, like there's a whole slew of, people loosely use this word programming into computer science, which is not. So I just want to make that point out. Programming is a kind of tool, like just like any other language you learn, you can express your ideas.
Okay, so you can learn to program without having to commit yourself to all of computer science then.
But it'd be good if you, obviously, if you're designing systems, you need to know computer science. But if you want to put a skill that you have into use, for example, you have photography, you want to be able to create photography-based service, or if you have accounting background, you want to be able to do accounting-based service, you could put programming as a skill. You can attach that skill, use your existing core skills and attach programming and create some new service. Like, for example, eBay, it's got nothing to do with computer science, but it's created a marketplace that people can go, trade their stuff, and that created tons of jobs, to your point, and, created a different kind of economy. So, the person who created, I think one of them has a computer science background, but I don't think, not all of them who did that as, programming background.
Mm-hmm. Now, since you guys are so involved in teaching code, what are some pedagogical tools or philosophies that are unique to teaching code, right? I would assume it's not the same as teaching.
No, it's actually very interesting because when we actually have a very separate team that thinks about code curriculum versus, say, like our user experience design curriculum or our business curriculum. And it's because it is a completely different experience. Now, I would say I 100% agree with you. Like, I would think of it more as a spectrum where, like, computer science is that underpinning of math throughout the thing and how to design these systems. But because that language started in that place, it sort of requires and encourages a certain style of thinking. It's probably not as true of the front end stuff. But so one of the coolest things I think about teaching programming is that it is so iterative, right? And it's so experiential. And you can, like I just said, you can code up something, see if it works. If it doesn't work, try and figure out why it doesn't work, and then fix it and then get it to work. And I think that iterative process and really being forced to problem solve very early on and just figuring out why something doesn't work, at least for me, and I think for a lot of the students that I've talked to, is a really fun experience that gets you to a place where you feel like you really understand like why something is the way it is and why it works and how to make stuff work. And it's also why traditionally it's been such a sort of autodidact's paradise to be a programmer, because it's something you can just sort of do in a solitary environment and learn as you go and continually push in new directions sort of as you want to in all sorts of different ways.
So I have a different take on how. So we deal with elementary, middle, high school children. So if you go to them and say, "I want to teach you programming," they'll just say, they'll laugh at you first thing. So because maybe some kids are really into it, but 99% of the kids are not. So, but what I think they have to look at it is that if you ask my son, he's into Legos. I want to build a Lego robot and train it to move around. So once you kind of know that understanding that they need to do some tasks, then that's when you need to introduce, okay, if you use a computer, you could program it. Or, my daughter says, look, I have this story, so why not write an interactive story? You can write a story that anybody else can, read, and you can write, create a few characters, write a story. So I think introducing that programming and logical thinking from that perspective gives more immersion for the kids. That what we've seen. Obviously, as you grow older and you already have a set of skills, whether you're a lawyer or or engineer, then the programming kind of gives you different learning to program. Then will give you probably how to apply my existing skills to create new services.
Mm-hmm. Yeah, I think the way that I came to code was understanding that it's kind of the medium of creative entrepreneurship, right? Or at least it is now. I think when I grew up, and I guess this dates me, but computer programming was this thing that people did in the back office to like run back office things, and like that didn't seem like a very creative endeavor. But now I see it as core to any creative entrepreneurship endeavor.
So I just want one point on that topic is that, the way I think about coding is like a glue. Like, math is thought as like underpinning for physics or any other science. So programming can be thought as the glue that can tie down these concepts to create something digital.
Okay. Let's see. How do we think after this question we should open it up to questions from you guys since we only have 30 minutes. So, how do you guys think about credentialing, certification, or otherwise, bundling some sort of statement about competency through all of these kind of explosive mediums, right? Of learning to code. Yeah.
I mean, I think in some ways it's like the holy grail, right? If we could figure out a way to just it's in a lot of ways there's a parallel, but it should be a lot easier than this to like that automated grading project that the Hewlett Foundation tried to get done of like how do you grade a paper and know if it's well composed and how many fancy words do they use, do they structure it the right way. Programming is already structured that way, so it should be very theoretically to look at somebody's code and say, oh, like this is the level that they're programming at. In fact, I've been telling my engineering team, who I've been working on a Skunkworks project around this, like, why can't you do this? I think there is a lot of subtlety to it that makes it more difficult to evaluate, which is why if you talk to people who are hiring engineers, they like to spend time with them and like have them whiteboard stuff, and they like to look at code they've already done. And so I think the certifying piece, you could say, does this person know how to build something in this language? And that's pretty easy to do, but I think there's not a lot of value there from what we've seen. And so what actually is valuable is how do they code? It's a lot like how do they write? Mm-hmm. And so coming up with very interesting ways to not just have a binary, do they know this or not know, but what level are they at is something we think a lot about, we haven't solved yet. I think when somebody solves that, there will be a huge demand for it, and it's going to be a giant business for someone.
Entrepreneurs?
I think credentialing is already there in most parts of computer science. There's computer science is a degree that people get. You can take exams and get credentials, but programming, there is multiple ways of solving a problem in the same language. So there is no one way to kind of correct way of solving it. So there are metrics like how efficient is it? How many lines of code are you using? Are you using 5 lines versus 50 lines? So that's where the efficiencies of same problem solving, because we know that what the output should be, and the efficiencies come into play. So in terms of the credentialing, I think ultimately it comes down to, are you testing the syntax of a language, or are you testing the logical concepts of a programming? If it's a logical programming concepts, then you can easily credential that, because you can say, here is a number of a set of numbers, sort them out. So you can write the design, then you can be able to test that whether the design is correct or not. So that credentialing is easy to do, but syntax-based credentialing is just like any other quizzing. I guess people figure out how to give certification to the complexity of this programming as they go on, different courses that are applied.
Cool. Well, now we've only got 10 minutes. See how short that was? Does anybody have any questions here? We've got to use the mic because we're recording this for posterity.
Probably a question for Krishna, but especially elementary and middle school, there's very limited time for other stuff. Math and English have basically displaced almost everything else just because of the pressures for tested subjects. When you talk to elementary, middle school teachers, principals, etc., how do you find places to squeeze programming in at the expense of your potentially an expense to some other subject?
So that's a good question. So the way different schools look at it differently, for example, a math teacher, like we have lots of schools using it, and I'll just give you my perspective. Like a math teacher is showcasing the knowledge of the geometry and functions that they are learning into creating something that they can showcase online. So it's just like a part of the subject they're learning, but they're practically applying it using a program. A science teacher is basically doing a little simulation. So what they're trying to do is that can the kids showcase their work, the knowledge they're learning. So yes, it takes a part of the timing, but they're trying to say, hey, there are practical implications. We'll be able to send a parent a link and say this is what they've created using the concepts they've learned, versus saying that they just know the concepts. So some schools are taking that leap and say, I want the actual creations out of the kid so that the parents actually see what they're learning versus we just saying they learned it. For example, very interesting things is we go to a music class. So they teach you how to read music. So they're able to compose music using a programming. So that's how different subjects are actually using program. That's why when I said it's a glue, they'll be able to glue that together and showcase their skill, even though they're musician, they're learning music. So
you said something earlier about it being sort of about logic, right? Logic's a huge part of and logical thought is sort of what programming can be taught at the sort of grade school level. Now, I mean, logic as a field sort of has been around for a long time. Is there a precedent from 100 years ago of teaching logic to kids, and at what point did that sort of go away?
I mean, so computer science came out of the logic is a part of math. There's like a Boolean logic. You have, there's a truth and false, and how you combine truth-false statements to do different things. That's how the programming language has actually been designed. So there is this concept of deterministic and non-deterministic languages. Like you can, English is like you can many ways of saying it. That's why computers can't understand natural language. There's so much, artificial intelligence. But if it actually has language, the machines exactly know what the steps they need to go through, perform that instruction, right? So in terms of the logic I'm talking about is it's more of a higher level logic. Let's say if you want to be able to store information, then you need to use, data structures or variables. If you want to be able to do something 20 times, then you use looping structures. So there's more different kind of logic elements.
Like if A, then B.
Yeah, that's. But then then the conditionals, if these two, like for example.
You guys are getting pretty geeky here.
Yeah. I mean, I'm saying he's asking a question about how they use. I mean, the logic is that they already know the logic elements, but they're just coding that in. If temperature is this much, and the humidity is this much, then the atmospheric condition might be this way. So if they were to kind of translate that, they'll use those two, temperature as a variable, humidity as a variable, and say if they test both the variables and if the conditioning, satisfies, do something. That's the logic that translates into.
Yeah. But as a public policy issue, Estonia has made it mandatory to teach basically application development, right, all through grade school. And I personally think that the best policy decision anyone could be making is to make app development a core part of the curriculum, like writing is, because writing it's essentially the same thing. It's manipulating information to create meaning for people, right? And most would call that writing, but I think that's also writing code. Yeah. More questions?
My only knowledge about this is Fortran, but I went back to school. So I'm just wondering, is this where you teach people to write code, very basic, start with the line by line, or is this where you start saying kids, well, look, these do that, these subroutines do that. Now we can put these together and we can create this bigger program. And therefore, at a younger age, they start producing these games and these high graphics. Or do you just simply want to teach? It's almost like teaching guys addition and subtraction, or do you simply give them a calculator and them go get more creative? What do you foresee teaching at that basic level, or being able to do bigger things with tools?
The bigger fun creative things, right? I mean, obviously you have to add and subtract, right? So the fundamentals have to be learned. But like you were just saying, if you try to tell a kid, hey, I'm going to teach you how to do computer science, they're going to roll their eyes at you, right?
Yeah, but I also think there's actually something really interesting in that question. From what I'm hearing, is that Estonians teaching app development, right? It's very different than teaching the logical building blocks. This way of thinking in a very logical way that you can use in music or in art, and then later that might be really useful in wanting to build something real. So the app development strikes me as like the engineering piece of it. It's like you got to learn science before you can learn medicine. Mm-hmm. And so it's like the question is, are we going to teach science to kids or are we going to teach medicine?
So here is a practical example. This is created by a third grader. So if you can see this is like a dog walks back and forth and eyes track the dog. And this has come out of some of our projects. So in terms of, you just have to teach them how to logically think first without introducing the syntax. meaning syntax actually comes into the way. If you start to introduce syntax, kids drop off. And then once they acquire the logical thinking, then you can bring in syntax so that they become proficient programmers, if they chose to become programmers.
So it strikes me that you all have been talking about coding in a very kind of linear linguistic mode, but there are also visual languages like Max MSP Jitter that I think students who are more visual learners can use to create all kinds of interesting artifacts, and I'd wonder if you could talk about that at all.
So Tinker is actually a visual programming language. We bring up, kids actually use Lego-like blocks to organize. But just so that there are like 20,000 programming languages out there. They all are different programming languages that are designed to solve different things. Like if you want to do databases, you want to manage data, there is a different programming language you do. If you want to create like web pages, you end up doing different languages. If you want to do an airplane operating system, you have to use a different language. So it's but all of these languages have same constructs, logical constructs. That's what we kind of a lot of people are trying to teach initially to kids, and then as they grow older, like when they want to choose some practical applications, and like as they both learned how to code. I'm assuming you learned to code in JavaScript or Python, one of those languages.
Yeah.
Then you pick a practical language and say, I have this problem, I want to solve what language I want to pick and solve that problem. So. But once you get the concepts of logical concepts, you just know, okay, this concept exists this way in this language. I just need to use it that way. So that becomes a syntax. It's like speaking Italian or German.
It's actually not as hard as learning Italian. Like you could take somebody who knows how to code in one language, and depending on how complex the language is, usually in a week they could take their concepts that they know in that language and apply them in that, because there's these basic things like variables, like loops, like conditional statements, and there's some and functions, and then you get object oriented, and so there's this sort of like fundamental building blocks which have been really built by engineers who've thought of like, how do we get computers to do the things we want them to do in the most efficient way. Those concepts, though, what's so interesting about it is that type of thinking. It doesn't matter if you're ever going to build an app or not. Like, it's cool to be able to build apps, but if you look at the history of like building apps over the last 30 years, like there have been cycles where it was really useful to know C, and then all of a sudden it was like, well, you really just need HTML to do something cool, and then it was, oh, you can just use this thing called Dreamweaver, and then it's Flash, and then you need to know JavaScript. It's sort of like there's sort of these ebbs and flows of how close to the metal you need to be. But I think as a discipline, this sort of logical thinking, these elements that really are how we set up the world are useful to kids and help them understand why things are the way they are. And I think that's sort of, it sounds like that's your mission or part of your mission. I think it's super cool.
And we are out of time. Leah, do you want to get one in? Okay. Special treatment for Leah.
Thanks, Michael. So my question is, I completely believe in coding for kids, but there's a skills gap that us as employers have right now that I can't teach my 8-year-old to code for me in the office today.
You
That's
probably
what I
could,
need.
actually.
Well, I could, but I need things that integrate with very complex systems. And there's movements like code.org and other things that I highly recommend everyone go sign their name to code.org if you haven't already. But how do you recommend that we help close the bridge of the people who we can hire and pay taxes today?
General Assembly?
Yeah, so I mean, now you're in my wheelhouse. So I think that's, at some level, that is GA's mission. We tend to think more from the student point of view than the employer's point of view, but feeding those needs for employers is a huge part of what we try and do. So when we build curriculum, we start with the employer and the need. We then look at what are the things that need to be taught and known in order to get somebody to be employable in that way. And then we look at what does a student want and what are their goals, and we make sure everything is aligned, and then we build that system. So I could talk a little bit about some of our challenges to scaling massively, but a big part of it is that it's a lot of time, it's a lot of investment of time and money to get one of these students going. And right now, for us, the students pay themselves. We'll be moving beyond that soon. But I would say that if you look at a lot of the infrastructure around giving people skills and just really enabling sort of economic self-determination that the government has set up, that nonprofits have set up, they're really focused on very old world things like manufacturing or like, getting people to go to college. And I think, to be honest, one of the main issues is that there's this giant gap between this kind of religious belief that we all have, and I'm guilty of it too, that like going to college is the best way to further your sort of economic earning potential over the course of your life, and looking at the reality of it, which is that you can go to college for 4 years, and not everybody, but a lot of people come out no more employable than they went into it. And so I think it's as citizens, we should be thinking a lot about, are we really deploying these resources? We're deploying a ton of resources towards this problem in just very, very nonsensical old world ways. And so taking a very close eye at like, what are the needs of the economy? How are we going to provide those skills? How many people do we need with those certain skills? How much investment? What's a good ROI, and how much should we be investing in this to get that kind of return on the other side? And these are questions that I think you saw this at lunch, but like we are in the very early stages of even talking about it, and people don't. And I really think even for us who are very thoughtful and think about this and are open to new ideas, this idea of college is this sort of sacred cow that, people need to go, like, that this is where it all happens is very, 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 very much in conflict with this idea of we need people with certain skills to do certain jobs. And a lot of that, and I'll stop talking because I'm just blabbing.
Except for ASU.
Except for ASU. ASU is awesome.
And I can disagree. You know what I mean? There's a difference of, yes, I need someone with skills, but I also need people with the knowledge to think and connect it to the business. And that's the role of higher education.
Okay, so there you go, right? So right in there is this like interesting tension, right? Is that in our society right now, we want college to be this place of coming of age, right? For people who are sort of adults, but not really yet. We want it to be a place of critical thinking and higher understanding, right? Of becoming a great citizen of the world, and then also preparing for your economic life. And what I'm saying is those things there's no like rule set in stone that those things have to be combined together. And I think one of the cool things that you see about innovative companies is that they're starting to figure out ways to disassemble that and create interesting new solutions that solve the problems a lot more efficiently than what we do now.
On that note.
Sorry,
Thank you.
no, it's okay.
Thanks, everyone.